This is lesson 5.3, part 4. What we are going to do is we're going to do the last graphing example. In this example, I'm going to do a mixture of a table and a mapping rule, just to have it nice and organized for you. So we're going to examine our function over here. It's a quadratic function. We know that because of the degree of 2. We're going to take a look at the different components that tell us what type of transformation is happening to our y is equal to x squared. Notice on the graph I've pre-drawn the y is equal to x squared in black ink over here, and I put the coordinates that I've used. I've used -2, -1, 0, 1, and 2 as my x coordinates, and I found my y coordinates using table of values and just plugging in my x values into the formula x squared. So now I'm going to see what transformations apply. In the table, I'm going to do a mapping rule based on the transformations that we analyze and discuss here. The first thing I want to point out is our A. Our A is equal to -1. So there's no stretching or compression, but that -1 means there is a reflection on the x-axis. So reflection on x-axis. So that's the first transformation that we'll do. And then we also have some translations happening. We actually have two translations happening if you look carefully. The first, if you look over here, is that our h is equal to 2. H is equal to 2. Positive 2. So what that means is we have a horizontal translation. Horizontal translation to the right two units. And then our k is 4, positive 4. And so what that means is we have a vertical translation up 2 units. And so what I want you to get is that reflections and compressions, they affect reflections, compressions, stretching, they affect our x value. They affect our x value. Or rather, I should say compression and, let me erase that there, because I misspoke. Compressions and stretching affect our y values. And reflection also affect our y values, not x values, I should say, our y values. So reflection and compression and stretching, they affect our y values. So we're going to go and modify our y value in our mapping rule to reflect, well, the reflection or the compression or stretching that we see. So another thing that's going to affect our y value is our vertical translations. Our vertical translations affect our y value as well. So there's two things affecting our y value here. We have our reflection, compression or stretching if there was, and then we also have our vertical translation. They affect y. The thing that's going to affect our x value is our horizontal translation. That affects x. So let's go take a look what's happening to x. For x, horizontal translation, we're moving to the right by 2. So what that means is any x value we had in x squared is going to become x plus 2. Our y, there's a couple things happening to it. First of all, we're doing a reflection. So that means our y is becoming a negative of itself, so negative y. But we're also moving it up by, I shouldn't have said 2 here. If you got confused, you were right, up by 4, because the k value is 4. We're also moving it up 4, so we're going to do negative y plus 4. And so here we have our mapping rule. We can take any coordinate from the y is equal to x squared and transform that coordinate to our final parabola using the mapping rule. And it's nice and organized this way. So I'm going to show you the work that's done. So we'll start with the first coordinate, -2, 4. So we'll change our x first. So our -2, we're going to add 2 to that. And then for our y, it's going to be -4 plus 4. And so our final answer is going to be negative 2 plus 2 is 0, and negative 4 plus 4 is 0. So this negative 2, 4 point over here becomes 0, 0. And it makes sense. We moved over to the right by 2. Where were we here? Sorry. So we were at 4 here. So we moved over to the right by 2 points, and then we had a vertical translation that also occurred. Now, I know you'd think we have to go up, but keep in mind that there was a reflection that happened as well. So the points will actually be starting from down here, and we'll see that in a minute. You'll see why it looks confusing at first, but then it'll make more sense once we draw more points in. Let's go take a look at our negative 1, 1 here. So negative 1 plus 2, and then our y becomes negative 1 plus 4. And so our final answer here is going to be 1, 3. So our negative 1, 1 is becoming 1, 1, 2, 3 over here. And then let's go try our 0, 0. So we have 0 plus 2, and then negative 0 is just 0, plus 4. And so that's going to be 2, 4. So 0, 0 is becoming 2, 4. So this 0, 0 point in the black behind there is becoming 2, 4. So 1, 2, and then 1, 2, 3, 4. Right here. Very soon you're going to see what we're trying to do here. Next we have 1, 1. So 1 plus 2, and then 1 plus 4 should actually be negative 1 plus 4 because of the negative y there. And that's going to give us 3, 3. So 1, 1 is becoming 1, 2, 3, and then 1, 2, 3. 3, 3. Now you can see the parabola starting to form. And then finally we have 2 plus 2, and then negative 4 plus 4, which gives us 4, 0. So 1, 2, 3, 4, and then 0. And then we can connect our dots. And then we can label this as y is equal to negative x minus 2 squared plus 4. And of course you could always extend down, extend down. So what I want you to notice is that, first of all, the reflection did happen. You can see we had a parabola opening from the top, now it's opening from the bottom. I also want to point out that our parabola shifted. The parabolas are not directly below and above each other. The parabola did reflect, but it moved over to the right by 2, and then moved up by 4. So for example, if we take a look at this point over here, the one we started off with, and we looked a little bit confused at first. This point here was negative 2 and 4. As a result of the reflection, if we applied that first, it would become negative 2, negative 4. So it would go negative 2, 1, 2, 3, 4 over here. And then, when you apply your translations, 2 to the right, 1, 2, 4 up, 1, 2, 3, 4, it became 0, 0, just as we start our mapping rule over here. So visually, it would have been a similar process. You take it, you change this to a negative because that reflection applies to the y, and then you do your translation after. Let's take a look at another point here. Let's look at this point over here. this point here was -1, 1. If we do a reflection first, it becomes -1, -1. So that's a reflection first. But then we have to move 2 to the right, 1, 2, and 4 up. 1, 2, 3, 4. And so we now have the point 1, 3. The reason it's 1, 3, not 1, 4 is because we were over here, and we moved up 4. We're at -1, moved up 4, so it becomes 3. You can do that with another point. You can do that with 0, 0. So 0, well, when you reflect it, it stays 0, because negative of 0 is just 0. And then you move over 2, 1, 2, and then up 4, like that. So our new vertex is up here. And you can figure out your vertex by just doing HK, 2, 4, which makes sense. And so you can do that with all the points visually to see that it makes sense in your table. Remember, start off with the reflection first, which applies to the y, and then your translations, horizontal and vertical. The horizontal translation applies to the x, and the vertical translation applies to the y. So make sure you apply the transformation to the right spot and apply them in the correct order. So again, for the y's, do your reflections, compressions, and stretches first, then do your vertical translations. And then for the x, simply do your horizontal translations as it needs to be applied. So what we've done is we've seen some examples of how to graph the vertex form by transforming the y is equal to x squared, using table of values for all the different transformations and plotting them on the same graph, and also by using the mapping rule. You should be able to do both methods. I would go back and try these lessons using mapping rule, using table of values, just so you become more efficient with it. You're going to start off doing this very slowly. It might take you 15 minutes to do one graph at first. But the idea is that the more you do, the quicker you'll become. So you should go from 15 minutes to do one graph to maybe 2 minutes to do a graph, or even less. So you'll become more and more efficient the more you do, and that's really the only way to do it. So practice the examples and do that. We're going to start off by taking a look at the practical application example here. We'll do a few of the questions together, and then we'll do a graph as well. So a rocket is launched into the air, and the rocket trajectory can be modeled using this equation here. So we have our vertex form over here, where t is the time in seconds and h is the height in meters. So when did the rocket reach its maximum height? So whenever we ask you for maximum height, I'm going to do question B first, the maximum height. What you're looking at is your vertex. The vertex is the maximum height of the rocket. You have a graph that opens from the bottom. We know that because of that negative there. So what we're really asking you is when did it reach this point here? So it went up and then eventually started going down, but this is the maximum height and that's your vertex. So to do a question like this, what I typically do is I find my vertex first. So I know my vertex is going to be 364. Now, we know that the height is your y value, because it's of the form y is equal to something x squared, and the t is the x value. So x, y, or t, h. So in this case, the maximum height is 64 meters. When did the rocket reach the maximum height? Well, it's the associated time with it in the coordinate for the vertex. So we reached the maximum height 3 seconds in. We know time is in seconds in this case. So you have to make sure you put those units down. So whenever you're asked for maximum height, that means the vertex, the time it takes to reach that maximum height is the associated time in the vertex. From what height was the rocket launched? So what we're basically saying is, at time 0, what was your height? The launch happens at time 0. We'll finish this question in the next video, but you can try it in the meantime before you go to the next video and compare your answers.